Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. Hi, everybody. Tonight, I'll be doing the review for test number 1. Let me remind you, test number 1, I will be giving this Thursday online. At that time, 8 a.m. or earlier, possibly earlier, I will send out an email with the password for the password protected PDF file for test number 1. And if you look at D2L, you'll go to the assignment area and you'll see here test number 1. Now, this doesn't open up until 4:30 a.m. on the 12th, so you can't see anything, but there's files there. There's a PDF file, and also files how to take a test. What you'll do is download the PDF file, open it up with the password, and you'll take test number 1. Now, if you don't have a printer like I have hidden right over here, well, I got to put away that. I got the fly. That's one of those electric fly killers. But anyways, if you don't have a printer, write out the answers. You don't have to do the problems on a piece of paper with your cell phone. Take pictures, and then use Cam Scanner to upload, make pictures that converts it into a PDF file, which you can upload to D2L. I'm thirsty tonight, I don't know why. If you have a scanner like I have with my printer, scan it and upload it. If you have a printer, print out the pages, write your answers, upload it as a PDF file. If you don't have a scanner, again, your cell phone and Cam Scanner. Now, one thing about Cam Scanner, it's a free app, but they also have, you can buy the one with all the bells and whistles. Don't. Just use the free version. My students have been using it for almost 4 years now, since the pandemic. All right. Now, in terms of the test, you'll get the password at Thursday, 8 a.m. or earlier, and you have until Friday, 8 p.m. to upload your answers. Now, when we were face-to-face, because I had to get out of the classroom, go to lab, when I would teach face-to-face, give a test, students would have 55 minutes. But I don't have to worry about that. So I've decided, take as much time as you need. However, don't cheat. Don't go on the internet. Don't ask for help, because I put things in my test that allow me to know when students do that. So please don't. And then when you're done, upload your answers. Just make sure you have them uploaded by Friday, 8 p.m. All right, before I start the review, there are 2 pieces of advice that will help you on tests 1, 2, 3, 4, and the final. Listen carefully. Remember, how many bonds to carbon? 4. Oh, I gotta get this finger fixed. 4 bonds to carbon, 4. And when you write down an answer, check when you write it down that you don't have a carbon with 3 bonds or 5, because it's always going to be wrong. I once had a student put something down where 6 bonds to carbon. It took me a couple minutes to stop laughing before I marked it wrong. All right. The other piece of advice is, except for combustion, you don't break carbon-carbon single bonds. It's rare. And in this class, except for combustion, you don't break carbon-carbon single bonds. Remember those 2 things. Now, the review you see right now is in the lecture section of D2L, cleverly named test number 1 review. And this is available for you to download. Also, I should mention, when I'm done tonight, I'll be posting this as a video. Also, by Sunday, 3 p.m., I will have the test number 1 grades in D2L. And at that time, I'll put an announcement, send out an email to everybody that the grades, the scores really are available. Also, by that time or sooner, I will send out to each one of you individually an email that contains the points you receive for each answer on test number 1. And then let's do it next Monday night at 7:30. Use the same login. I'll put out an email on this. I will go over all the answers for test number 1. I like my special effects. But anyways, I can do it with both of them. Nope. But anyways, I'll do that. And if you can't make it next Monday at 7:30, I will have a video and I'll post that, but as a private video in my YouTube Chem 170 channel, and I'll send out an email with the link to the answers. All right, let's get going. All right, some definitions you should know. Hint, what's a hydrocarbon? It's a molecule with only carbon and hydrogen atoms. Now, there are 2 types of hydrocarbons, and you should know what they are and how to define them. And that's a saturated hydrocarbon, because it's a hydrocarbon, it's a molecule with only carbon and hydrogen atoms, and because it's saturated, in which all carbon-carbon bonds are single bonds. Unsaturated hydrocarbons are molecules with only carbon and hydrogen atoms that contain one or more carbon-carbon multiple bond, which is known as a double or triple bond. Now, I use the term, but I'll never ask on a test what's an alkane or cycloalkane. Now, you should know, and hopefully you've done the practice problems. And by the way, test 1, you'll see is alkanes, cycloalkanes, alkenes, alkynes, and aromatic compounds. Now, you should know how to draw alkanes and cycloalkanes. And remember, I will ask, give the IUPAC structure. That means, or the name, either way. There's 2 types of nomenclature naming questions on a test. One is draw the structure from the IUPAC name or common name. The other one is give the IUPAC name for the structure. And you should be able to identify the longest chain. And based on that, you should know the alkane names 1 through 10. There's a file in D2L lecture where I have this. Next, on molecules, we have alkyl groups. Those are left over after you determine the longest chain. And there are only a couple I asked you to learn. And here they are: methyl, ethyl. Now there's 2 3-carbon propyl alkyl groups. When it's to the N carbon, it's N-propyl. When it's the middle, it's isopropyl. For 4-carbon alkyl group, there are 3, but one of those, I think I've only seen once used in the last 30 years, so I don't teach it. But these 2 I do. And that's when you have 4 carbons and the N carbon is attached to the chain or ring, it's an N-butyl group. When you have 4 carbons and a center carbon has 3, 1, 2, 3 CH3 groups attached to it, and that center carbon is attached to a ring or a chain, we call that a tert-butyl. And as you've seen by now, organic chemists are lazy, and I normally call it a T-butyl. On a test, you can put either one. All right, now, if on a test you were to say, give the IUPAC name for the following, what do you have to do? Find the longest chain. If we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's one chain, but there are others that could be, and you have to check. I can start here. 1, 2, 3, 4, 5, 6, 7, 8. And I could have also gone here 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. Now, it just so happens I wrote it so the longest chain is across. It doesn't have to be. And therefore, the longest chain is this. And 9, you should know, is no name. Now, am I done? No. We have these two alkyl groups. One carbon is methyl, 2 carbons is ethyl. Now, you number it always starting from the ends of the chain. Students like to say, oh, here's the first carbon. No, that's not. The first carbon in an acyclic alkane has to be one of the 2 end carbons of the longest chain. And if we start this way, the methyl group is on 3, the ethyl group is on 4. If we go the other way, 1, 2, 3, 4, 5, 6, 7, then the ethyl is on 6, the methyl is on 7. We number in such a way that the alkyl groups get the lowest numbers, which would be 3 and 4. So I'm not going to hold you to alphabetical order of the names that IUPAC has rules for. I hold myself. So this would be 4 ethyl, 3 methyl. I'm running out of room here. Sorry about that. Give myself some more room. By the way, I highly recommend take a test in pencil so you can erase something. And there we have 4 ethyl, 3 methyl, no name. Since I'm not holding you to the alphabetical rule, E comes before M. If you were to put down 3 methyl, 4 ethyl, no name, I give you full credit. Don't tell the IUPAC police. Now, another thing I'd like to point out is a ring. In a ring, you count the number of bends. Each bend is a carbon. So 6 carbons would be hexane, but it's a ring. Don't forget cyclo. If you just put down hexane, it's wrong. It's cyclohexane. Now, with a ring, when you have one substituent, you do not use a number because it's always going to be on carbon 1, wherever it is. Don't forget, a ring can rotate, and therefore you don't need a number. Now, we have how many carbons in the ring? 1, 2, 3, 4, 5. That's pentane. But it's a ring cyclopentane. And what do we have here? An isopropyl group. no number. I'll take off points if you do put one, because you don't. And it'll be isopropyl cyclopentane. Now, when you do have something, and let's do this one. We have a ring, 6 carbons, 1, 2, 3, 4, 5, 6. And we have not one, but 2 methyl groups. So 6-membered ring is cyclohexane. By the way, Mother Nature and Dr. White love rings, 5 and 6-member rings. All right, so we have a methyl group. And there are 2 of them use di. Di prefix is for 2, tri, 3. I've rarely ever seen 4, which is tetra, or more, which is why I don't teach it to you. Next, you have the 2 alkyl groups, and one of them is going to be 1 and the other 2. Now, when you see this di here, you better have 2 numbers in front. So this would be 1, 2, dimethyl cyclohexane. And if you go back and look at the videos, you see, and the practice problems, I have a lot of this done. Now, one of the things I like to do in this class is bring in the real world. Dr. White, oh, do I have a spelling error there? There we go. Has worked in the real world for many decades. And if we think about alkanes, where do you find them? You should know. You can find them in natural gas, which is methane. Propane is the stuff in the white tanks for your barbecue. When you go to a gas station, the gasoline is a very complex mixture, and a lot of that mixture are alkanes like octane. Vaseline is longer chain alkanes. Baby oil are long chains, and candles, which are made up of 50% paraffin wax, are very long chain alkanes. Now, the only reaction for alkanes I've asked you is if you have an alkane, I should also have your cycloalkane. And react it with oxygen. You need a spark, but I don't put that down to a heat source. You have combustion. And the actual chemical products are carbon dioxide, CO2, and water. You also get heat, which is important. In my class, you don't have to balance equations. So if I were to put this on a test, 3 points each, give the products for, when I say give the products, that means draw them down. And if you're doing an organic structure, which this isn't, be sure to do the actual structure, not the empirical formula. But in this case, what do we have here? An alkane. It could have been a cycloalkane. And plus oxygen. This is combustion. I get carbon dioxide plus water. Therefore, the answer here is carbon dioxide plus water. And that's the beauty of general equations. Now, let me point out something. Some of my best students, top students I've ever had, under each reaction where I ask you to give the products, they write the general reaction. it helps them. Some of the best students I've ever had don't write the general reaction, but they have it in here. Either way you choose, I don't care, whatever helps you out. All right, next, let's talk about alkenes and alkynes. An alkene is a carbon-carbon double bond. An alkyne is a carbon-carbon triple bond. And you should know, hint, that an alkene has one sigma bond and one pi bond. Alkene, one sigma bond, one pi bond. By the way, each one of these lines represents 2 electrons. Each bond represents 2 electrons. So we have a sigma and a pi. In an alkyne, a triple bond, we have 1 sigma, but now 2 pi. 1 sigma, 2 pi. And here's a mistake. Oops. Sorry about that. It should be YNE. Everybody correct that on yours. I'll try and correct it tomorrow morning. But anyways, for an alkene, a double bond, find the longest chain, name it as an alkane, drop the ANE ending, put ENE, and a number for acyclic plus if you need cis or trans. No number or cis or trans for cycloalkenes. In a cycloalkene, one of the carbons of the double bond is always 1. So let's take a quick look at this. Just checking to make sure you see the right slide, and you are. And the question is, give the IUPAC name. And here you have to find the longest chain, but from now on, you should look at a molecule and look for what's different. What's not a carbon-carbon single bond or carbon or hydrogen atom should get your attention like that. And we have a double bond here. So I find the longest chain with both carbons double bond. 1, 2, 3, 4, 5, 6, 7, 8. If we went down here, 6, 7. So 8 is the longest chain. And 8, you should know, is octane. But since we have a double bond, drop the ANE and put ENE. Next, what's the lead carbon, the carbon double bond closest to the end of the chain? That's on carbon 3. So that's 3-octene. Now, notice on each carbon of the double bond, we have a hydrogen, and they're on opposite sides of this plane. And when that happens, that's called trans. Same side, that's cis. Well, this is opposite, so that's trans. 3-octene. And then we have, oh, it's our old friend, the methyl group that's on carbon 6. So this would be 6-methyl trans 3-octene. Now, in a ring, it's always going to be cis in the ones I've ever encountered. I think twice in my career since 1978. Oops, I shouldn't have said that. Actually, 77 is when I got my PhD. I've seen a trans double bond or ring. Other than that, they don't exist in real world. So if I look at this molecule, what's different? A double bond is in a ring. There's 5 carbons in that ring. So that's cyclopentane, drop the ane, put ene, cyclopentene. Now, when you number it, one of the carbons of the double bond has to be 1, the other 2, and you number it in such a way that one is 1, the other is 2, and it has the alkyl groups with the lowest number. So if I start 1, 2, 3, you don't need a number here because one of the carbons is always going to be 1, but this would be 3-methyl cyclopentene. Now, let me just show you one other mistake students have. They'll call this 1 and this 2. Wrong, because if this is 1, this has to be 2, 3, 4, 5. So you have 2 choices, 3-methyl or 5-methyl. And hopefully you all know 3 is smaller than 5. And that's how you do nomenclature. For a triple bond, find the longest chain, drop the ane, make yn, change to yne, and then you also have to put a number where the carbon of one of the triple bonds is closest to the end of the chain. Now, I think many years ago, I saw one example of a triple bond in a ring. In the real world, you're not going to see that. All right, let's talk about reactions. Here are general reactions. Whenever you have a double bond reacted with hydrogen and catalyst, the catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon of the double bond gets a hydrogen. And here, these type of problems, I'll ask, give the organic product. And later on, you'll see sometimes it's more than one, or products, or the following. And let me finish. And you look at that and you say, what's different? And immediately you have a double bond. And we're reacting with hydrogen. And what's nickel? It's a catalyst. And the catalyst can be nickel, platinum, or palladium. And what happens You break the pi bond, and each carbon of the double bond, these two carbons, become these carbons with a hydrogen on each. Do you break carbon-carbon single bonds? No. Well, if I start with 3 here and I'm not doing combustion, oxygen, I'm not, then I'm going to end up with 3 carbons. Now, here are my 2 carbons of a double bond. And it's important you pick the right 2 carbons and you break the pi bond. So instead of 2, there's only 1 bond there. Each one gets a hydrogen. Now, there's 4 bonds to carbon. This carbon has 3, 4 minus 3. 4 minus 1 is 3. This carbon has hydrogen and 2 bonds here. 4 minus 3 is 1 hydrogen. And the N carbon here has 2 bonds, a hydrogen and a carbon. There should be 4 bonds to carbon. 4 minus 2. Oops. Yep, that's right. Now, if you wanted to, you don't have to. You could have also written it this way. I would recommend you do that because that's one less thing you got to do in your mind where you can make a mistake. And whenever you see a double bond, this will always happen. You break the pi bond, and 1 carbon gets H, and the other gets H. Now, in organic chemistry, just like in math, X and Y are numbers. X means fluorine, chlorine, and bromine or iodine, the halogens. And when you have a double bond, a reactor with halogen gas, X2, you break the pi bond, and each carbon of the double bond gets a halogen. Now, what happens when you're not adding the same thing to each carbon? And that's called unsymmetrical addition. And here, the first example, we have HX, where X can be chlorine, bromine, or iodine, reacting with a double bond. You break the pi bond, 1 carbon gets hydrogen, the other gets the halogen, and it follows Markovnikov's rule. The carbon with the most hydrogens gets the hydrogen, the other carbon gets the halogen. Let's look at that. And if I were to ask if the organic product or products are the following reaction, well, you look for what's different, what's not carbon, what's not hydrogen, should get your attention like that, or like that. And we have a double bond. Everything else is going to come along for the ride. Double bond, HCl, Cl is the halogen, which we show by X. That can be chlorine, which in our case it is, bromine, Br, or iodine. And you break the pi bond. Remember, there's 1 pi bond and 1 sigma bond. You don't break sigma or single bonds. And 1 carbon of the double bond gets the H, the other gets the X, and it follows Markovnikov's rule. The carbon with the most hydrogens of the double bond carbons gets the hydrogen, the other gets the halogen. Well, if we look up here, this has 1 hydrogen, this has 2. And which is the larger number? And time's up. Hopefully you pick 2. So do you break carbon-carbon single bonds? No. So I have 4 carbons across and a methyl group. Here are my 2 carbons of the double bond. I broke the pi bond, which is why you only see one bond between those two carbons. And the N carbon has the most hydrogen, so it will get the hydrogen from here. And the other one will get the halogen, in this case chlorine. And now I know there are 4 bonds to carbon. I didn't break any carbon-carbon single bonds. And there's your answer. And that's how you do Markovnikov's rule. Now, similarly, if you have a double bond and you add acid catalyst, which we show as H+, that can be a sulfuric acid and a lot of other catalysts I don't teach in this class, and water. Think of water as H and OH. You break the pi bond, and one carbon gets the H, and the other gets the OH, and that follows Markovnikov's rule. The carbon with the most hydrogen, the double bond, gets the hydrogen. The other carbon gets the OH, which you'll learn later on is called the hydroxyl group. All right, let's look at alkynes. And here we have 2 pi bonds and 1 sigma. And when you break each pi bond, each carbon gets a hydrogen. When you break 2 pi bonds, each gets 2. The organic chemists are lazy. We are. And instead of balancing this, I use H2 bracket, the letters X and S, close bracket. And that's shorthand for excess. That means you got all the hydrogen in the world that you would need to break the pi bonds and add hydrogen to the triple bond. And the same thing is true for halogenation. X2 is a halogen. You have 2 pi bonds, and you break those 2 pi bonds, and each carbon of the triple bond gets 2 halogens. And again, since organic chemists are lazy, we use XS. So if I take this molecule and ask, give the organic product or products for the following with this reaction, what's different? A triple bond. What are we reacting it with? Halogen gas, bromine, but notice it's excess. And remember, X can be, in this case, fluorine, chlorine, bromine, or iodine. Remember, there's 2 pi bonds, 1 sigma. Pi bonds I can break like that. Sigma, single bonds, you never break, except for combustion in this class. So I break the 2 pi bonds. Each carbon of the triple bond gets 2 halogens. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4 carbons. I'm going to end up with 4 carbons, which are the carbons of my triple bond, which are these 2 carbons. And my general reaction tells me each one gets 2 halogens, in this case, bromine. And I know there are 4 bonds to carbon. The bromine counts as 1. There are 2 of them, that's 2. And I can put in the hydrogens. And there you go. Now, there's one thing I mentioned in my videos that I like to point out. And if we look at this molecule and what it's reacting, give the organic product or products, I look for what's different. Ooh, a double bond. Wait, there are two of them. Now, when double bonds are separated by one or more carbons, which this is, they're not directly connected together, they react as if they were alone. I'll say that again. When a double bond is separated by one or more carbons, each double bond, when you like in this case, you have two, react like they're alone. Now, if we look, I have a double bond here and another one here. So each one is independent, reacted with hydrogen and a catalyst. Catalyst can be nickel, platinum, which it is in this case, PT, or palladium, PD. And you break the pi bond, and each carbon gets a hydrogen. Now, why did I put this excess here? Because you have two double bonds, and I don't want to balance that. And I need 2 moles or molecules of hydrogen. So I just put down excess. That means I got all the hydrogen in the world that will react with anything hydrogen can react with. Now, you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5 carbons. I better end up with 5 carbons. And this first double bond right here, I broke the pi bond, and each carbon gets a hydrogen. The second double bond, I broke the pi bond, and each of the 2 carbons gets a hydrogen. I know there's 4 bonds to carbon. And there's your answer. That should be a 2. And there you go. Next, I talked about aromatic compounds. And those are compounds that have really strong or great stability. And the 2 I talked about to begin with, mainly in this area, is when you have a 6-membered ring with 3 alternating double bonds. You can write it this way or with a circle, and that's called benzene. IUPAC in their infinite wisdom said, oh, we're not going to get these organic chemists to call this anything else. They've been calling that benzene for centuries. So we'll call it benzene. Now, when you have a methyl group on a benzene ring, it's not methylbenzene. For eons, that's been called toluene. And IUPAC did the same thing. Now, remember to put the double bonds or a circle. Really, this should be also right here. Dr. White likes to see the double bonds, not the circle, because I think it just looks cooler. Dr. White is always trying to be a cool dude. All right. So when you have di-substituted, you don't use numbers. Use the term ortho for 1,2 di-substitute on a benzene ring. Meta is 1,3, para is 1,4. Now, at this point, I introduced some new substituents. Cl is called a chloro group. Fluorine F is a fluoro group. Bromine, Br is a bromo group. Iodine, I is iodo group. And another very important one, NO2, where the bond goes to the nitrogen, not the oxygen. That's called a nitro group. And if I were to ask you to draw the IUPAC structure or draw the structure for, and I give you the IUPAC name, benzene, well, that's this. Or this one, or this way. If you were to draw the following, this is wrong. Why? Because this is cyclohexane. And don't bother to ask for partial credit, because this is as different from this as your hand is, in my mind, to your foot. And if I were to ask you to draw a picture of your hand and you drew a foot, would you expect partial credit? No. So same thing. Remember, put in the bonds in the ring for benzene or toluene or the circle. If you don't, you're going to get it marked wrong. Now, if I were to ask, give the IUPAC name for the following, how do you do this? We look here, ooh, 6-member ring, but it's got 3 alternating double bonds. That's benzene. And it has on there a bromo group and an ethyl group. Now notice it's di, meaning 2 substituents. And they are 1, 2, 3, or you could have also counted the other way, which most of you would do, 1, 2, 3. And if we go back and look here, 1, 3 disubstituted is meta, 1, 2 ortho, 1, 4 para. But this would be meta. So it would be meta bromo, and this is an ethyl benzene. Now, if you had put meta-ethyl bromobenzene, I would give you full credit because I'm not going to hold you to the alphabetical rule. Don't tell anybody I'm being nice. Shh. And if there's more than 2 groups, you use numbers. Now, when you have something like this, let's look at this structure. We have a benzene ring, but notice you have a methyl group. So that's toluene. This is number 1 always. And when you have more than 2 groups, you use numbers and you number in a way, clockwise or counterclockwise, to give the alkyl groups the lowest numbers. So here we would have 4 N-butyl, 2 ethyl toluene. Now, if you had put down 2 ethyl 4 N-butyl toluene, I would give you full credit because I'm not holding you to the alphabetical rules. And remember, the other substituents are chloro, chlorine is chloro, fluoro, fluorine is fluoro, bromine, bromo, iodo, and NO2 nitro. If you go back and look at the video on this, I talked about TNT 246 trinitrotoluene, which is an explosive used in dynamite. Now, when it comes to aromatic benzene or toluene reactions, you don't break the double bonds in a ring, because those double bonds, pi electrons holding hands, gives it all very large or very strong stability that it doesn't want to lose. So we have what's called electrophilic substitution, aromatic electrophilic substitution. And one of the hydrogens on the ring is replaced with something else. Now, in the first reaction, if you have halogen, chlorine or bromine plus ferric tribromide, you replace one of the hydrogens with the halogen. Now, as I mentioned in class, if you had something already on the ring, I would have to talk about what's called directors. We will do a lab with that, but not in class, because they're more important things. Because after this class, I don't think any of you are going to do electrophilic substitution, aromatic substitution. But you will deal with carbohydrates, proteins, and fats and oils. I'd rather spend more time than that than teaching you directors. So what that means is all the reactions I can put on test number 1, and also later on the final, will start with benzene. Well, in that case, there are only 2 examples here. When BX is chlorine, that's a chlorine. When X is bromine, that's a bromine. Now, next one, you take benzene, react it with HNO3, nitric acid, H2SO4, sulfuric acid, you put a nitro group on that. Since I'm always going to start with benzene, this is the only reaction I can show you for this one, because I'm not doing directors. Next one, if you have benzene reacted with sulfur trioxide and sulfuric acid, you put on a sulfonic acid group, which I didn't ask you to learn the name. And remember, the bond is from the benzene ring to the sulfur. Excuse me, I forgot to mention, students put NO3 for nitro group, and I marked it wrong. Even though this is HNO3, this becomes HNO2 on the ring. On here, it's to the sulfur. We'll learn later on this reaction helped make, at the end of World War II, the molecules that we now use for our laundry detergent. A derivative, something made from sulfonic acid on a benzene ring, are the key ingredient in your laundry detergent, whether it's Tide, All, or other brands. And later in the semester, way later, I'll teach you about that. And finally, and this is the only reaction I can ask you here, because I'm not going to have substituted benzene rings. And finally, the last one, Friedel-Crafts alkylation. 2 chemists, Friedel and Crafts, are honored for their work because this reaction is named after their discovery. And this is one of those special rare reactions where you make a carbon-carbon single bond. And let's go through an example. And if we look at this, and if I were to ask you, give the organic product or product for the following, what do? Well, you look for what's different. Oh, here I have a benzene ring. And here I have carbon, hydrogen, carbon, ooh, a halogen. And I also have, remember, halogens are abbreviated by X, just like in math, use X, Y, and Z. Organic chemists for halogens use X. We have aluminum trihalide. X's can be chlorine or bromine. In my experience, it's usually chlorine. And what happens? You do that very special thing. From the benzene ring, you form a carbon-carbon single bond to the R. R is like X and Y in math. This is something with carbon and hydrogens. But this bond here is to the carbon that has the halogen on it. So if I look here, this is my R group. This is the carbon with the halogen. Do you break carbon-carbon single bonds? No. So I end up with my benzene ring, which my general reaction. Don't forget to put the double bonds in there. That's cyclohexane, and I mark it wrong. Then my R group is 3 carbons. The N carbon has the halogen. There's 4 bonds to carbon. I didn't break any to carbon-carbon single bonds in R. And I get N-propylbenzene. And with that, I'm just about done. Let me remind you on test number 1, there'll be one synthesis problem where I ask you to give the starting material for this reaction. I went through those in my videos, so take a look at those. And don't forget, Thursday, 8 a.m. or earlier, if I get up earlier, which I usually do, I'll send out the password for test number 1, and you'll have until Friday, 8 p.m. to take test number 1 and upload it to the assignment area of Blackboard. I mean, D2L, wrong school. The other school I teach at, it's called Blackboard. Bad Dr. White, bad Dr. Anyways, to D2L. Now, tomorrow, Wednesday night, I'll have my office hour from 6:30 to 7:30. So if you have a question, come on by and ask. Also, during the test on Thursday and Friday, I'll check my email about every 2 hours or so. And on Friday morning and part of Friday afternoon, I'll be busy, but I'll check. If you have a question, email me. Because remember, in my class, there's no such thing as a dumb question. With that, I'm done for the evening. I'll do my normal Gehen gesund, which means go in health. Be careful, COVID's still out there. My personal trainer at the NCH Wellness Center, she came down, her son brought home COVID from school, and she caught it, and she's still sick. Luckily, she had her boosters like I have, and she's got a bad cold, but still, I'm still wearing my mask. So, Gehen gesund, that's Yiddish for going out, and you know what's coming next. Bye now. I stole that from Granny and the Beverly Hillbillies. Bye.